to this point. Graphing a line, that's what we're doing in this unit. And there's been a lot of different ways that I've asked you to do it, right? So I've said to you before, hey, graph y equals 3x minus 1 with a given domain. And if that domain was like, say, 0, 2, and 4, those are the only numbers your domain can be, your graph looked a certain way, right? So we're still kind of at that point where in order to graph lines, we haven't really dove too deep into and learned the ins and outs of it. We have to create a table of values. And when your domain is specified, you can only put certain numbers in there. And they're telling you can only use 0, 2, and 4. Okay, let me point something out. Remember yesterday how I told you to show you how to solve an equation for y because it's really easy? All I do is put 0, 2, and 4 there. I don't have to solve any crazy equations. 0 times 3 is 0 minus 1. 3 times 2 is 6 minus 1. And 4 times 3 is 12 minus 1. Right? So you know that when I plot, or when I substitute that in, I get a range value. Agreed? So now that I have an ordered pair in my table, I plot it, right? Now be careful because I said 0, negative 1, 2, comma, positive 5, and 4, comma, positive 11. And if that happens and it's semi-close, you can just kind of go off. So let's watch what we did. We've already done this. I'm building off of this. I gave you a function. I gave you a domain. I asked you to graph it. And I'm done. Do I connect these points right here? No, because I've been prepping you to understand what domain means. Domain means your x values. When I go to make these ordered pairs, the only numbers that my x values can be are 0, 2, and 4. Because if I follow these points back to the x-axis, because that's my domain, it better only be highlighted at 0, 2, and 4. And by taking a ruler and connecting them, you're telling me it can be anything in between. And by connecting them and putting arrows on the end, you're telling me it could be any number in the world. And it can't. It can only be these three. So are you good with that so far? Okay? So then, yesterday, I took that domain restriction away, didn't I? I said, hey, I want you to graph 2y minus, let's say 3x minus 2y equals 12. I asked you to graph that, right? And I didn't say anything about what your domain had to be. Here's what you need to know. If it just says graph it and nothing about domain, you pick whatever you want your domain to be. And how many points do you need to make a line? 2, okay? 3 is helpful. Does that give you a good sampling of data points, negative 1, 0, 1? Yes. But you know what? This is in standard form. I'm going to solve it for y real quick. So to do that, I'm going to cancel out my x term, right? This is a review. I'm building on this to show you how today's going to affect you. Equals, I'm going to put my x first. Then I'm going to divide by negative 2. Okay? Actually, you know what I'm going to do, just for the sake of super, super easy right now, I'm going to make this a 4. Alright, if you already have it there, you'll see why in a second. So let's make this a 4. So when we do this, and we have a 4x here, okay, that's going to give me y is equal to positive 2x minus 6, right? So now when I put negative 1, it's a quick, easy thing. Negative 2, or 2 times negative 1 is negative 2, and negative 2 plus negative 6 is negative 8. 0 minus 6. 1 times 2 is 2. 2 minus 6 is negative 4. I have my ordered pairs. Those are the ones I chose. It didn't say I had to choose those. Now when I plot negative 1, negative 8, and 0, negative 6, and 1, -4. Am I done? No. I get to take this ruler out, put it on these points, and I have a nice big linear function that I've connected the dots, I've put arrows, because there is no domain restriction, right? X can be whatever you want it to be. Are you following me? Okay. So guess what? This book, man, they got you all over the place. Here's a domain restriction, here isn't. Guess what we're going back to? Domain restriction. So we've done both of these examples. I want you to kind of move over to this bottom one here, but it's going to be a little different. So I want you to kind of think about what this means. If I asked you to graph y equals -1/2 x plus 4 with a domain restriction of this, we got to think about what that means. That means, well, they're not coming out and saying x can only be 1, 2, 3. It can be what?
Anything above or equal to.
Yeah. You can pick whatever values you want, but they can't be less than 0. So is it kind of like a half domain restriction? So let's talk about what this is going to do for our table. So the first thing you need to know is that whatever number they give you as your restriction, it's going to be your very first domain point that you choose. And then you know what? I'm going to just choose 2 more. What's the next number? You don't need to get silly here and choose 100 and 500. Choose 0, 1, 2. Actually, in this case, I don't want to choose 0, 1, 2. I want to choose what? Good. Because whatever number I choose, I'm going to put right there and take half of it. And I don't want to take half of 1. I want to take half of 2, and I want to take half of 4. I could also have chosen -2, 0, +2. That'll have worked. Okay? Now, because it's solved for y, I just have to take half of 0 and add 4 to it. I have to take half of 2, which is 1, but make it a negative, -1, and then add 2 to it, and I get what? Wait, where are we at? Yes, you have take 2, take half of it, that's -1, plus 4, that's going to give you 3. Take half of 4, make it a negative, and negative that plus that gives you this, right? Okay. Now is the moment of truth. Actually, no, not yet. Let's plot our points. Okay? Let's plot 0, 4. Can it be 0? Yes. I don't know if you noticed, but I did put a darkened in, colored in circle, a closed circle. That's going to change in next problem. Let's plot 2, 3. Yeah. And let's plot 4, 2. If they told me your domain can only be 0, 2, and 4, I'm done. If they told me no restriction, do whatever you want, I would take a ruler and I would connect them. But you're already thinking, they're telling me that all of my x values can be anything I want as long as they're greater than or equal to 0. What do? This is the moment of truth. Go ahead, Ben. It's going to be, actually, I love the fact that he said a line segment. It's going to be a ray. Very good. What does array mean? Array has an arrow on one end and an ending point on one end. We are going to do ones with segments, though. But now the question is, holy cow, where do I go with it? Which end has the arrow and which direction do I go? I have a big bit of advice for you on that. If I were to plot this like I asked you to a couple weeks ago on a number line, wouldn't I put an open or closed circle here? And aren't all these numbers greater than 0? So this part of my graph is going to be the part that is in my domain. So I'm going to do this. Because where on the graph is it greater than or equal to 0? Right here. I don't need the blue. I just need you to know that it goes here and that ray goes in that direction. Connor?
Do you have a standard form equation? Do you have to change it to slope-intercept in order to
No, we're going to learn something in next section called, his question was, do you have to change it from standard form to slope-intercept every time? No, and there's going to be one that it's actually going to be easier to find the intercepts, something called the intercepts, so no, you don't have to. It's just for now it's a little bit easier. Okay, did that make sense to you? All right, so now I'm going to put the domain down. So you see the difference between the three? Here's a domain restriction, but it's only really on one end, right? So if I were to say, plot, let's talk about, let's ask you this one. So if I were to do y is equal to 2x minus 1 with a domain less than 0. Actually, we're not going to use 0 every time. Let's make our domain less than 4. Okay? So my domain has to be less than 4. Which means, and I actually have kids will do this, they'll go to the x, they'll go to 4, and they know that less than is this. My graph, whatever I decide to do with my line, can only exist in this part. There had better be nothing over here, because that's a domain that is greater than 4. And my domain can't be that, okay? So, let's take a look at our table of values real quick. So our table of values is going to look like this, x, y. What's my first value going to be? Now, this is debatable because a lot of people will say it has to be less than 4. So you can't put 4, you have to put 3. What's my answer to that? I understand 3 is less than 4, but by putting 3, I am forgetting about all the numbers that are less than 4, right? But still greater than 3. So instead of putting 3, I'm going to put 4 and use what kind of circle on my graph? Good, an open circle. So I'm going to use 4, 3, and 2. And so now 2 times 4 is 8. 8 minus 1. 2 times 3 is 6. 6 minus 1. And then 2 times 2 is 4. And 4 minus 1. So I have my ordered pairs. Let's plot them. 4, comma 7. Be careful. Because your instinct is going to be to go, whoop, there's a point. But can it be 4? No, it has to be open circle. It has to be less than 4. That is going to be a conceptual error. If that is the only thing you do on the assessment, it will count against you. Because you need to know that it's not part 4 is not part of your domain. Then I'm going to graph 3, comma 5. After that first one, they could all be colored in, it doesn't matter. And then 2, comma 3. Now, let me ask you this. Without the blue highlighter there, it could be confusing, right? But I have my blue highlighter there. I know that my graph has to exist less than 4. Understand? Okay? So, let's practice a couple more of these. Go ahead and flip the paper over to the back. And I'm just going to give you a domain and ask you, actually I'm going to write the domain in and ask you to tell me it. So, if I put closed circle here, just go to point 3, 2 on any of your graphs. And I don't care about the slope of it. Just draw something with an arrow to the left, or to the right, sorry. What is that domain? Domain means X value. It can only exist to the right of that number. This domain is what? It can't just be 3, because if it's a domain of 3, then my line is straight up and down. Greater than or equal to 3. Okay? Go to this graph. Put a point at -5, -2. Make a line going in this direction. And this one I want to point something out on. So I went to -5, -2. I drew an arrow going this way. Follow it up to your x-axis. My graph is only existing to the left of what number on the x-axis? -5. Can it be -5? No, my domain has to be less than -5. Here's what some people say. What do you mean it has to be less than? Your arrow's going up. They were thinking less than means the arrow has to be going down. No. It has nothing to do with up and down. It has to do with to the left and to the right of. Understand? Okay. Why is it important to do this? Because, go back to the front, you're not done. Because part of the final piece to this problem is going to be, all right, now that you graphed your domain correctly, what's the range? So, I'm not going to actually tell you. I want to see if you can apply it. So, this question, I want you to write this down right now. To find your domain, you ask yourself, how far left, how far right? Agreed? Because isn't that what the x-axis is? So your domain answer is how far left, how far right. Which then means your range would answer what question? Good. How far up? How high up can your graph go? How low down can your graph go? So look what I'm doing. I'm not using a blue highlighter on the x-axis anymore. I'm going to get a different color and follow it over. So how high up can this graph go? This one, if you're looking at your graph, I know it's small, it can go as high as 4, but it can't go higher. So look how I'm going to write my range. R has to be less than or equal to 4. Got it? Now let's look at our range for this other one. Not how far left or right, how high up can this graph go? It can go all the way to 7. It can't be 7, and it can't be higher than 7. How do we write that? My range has to be less than 7. Do you follow? Flip it over and find the range for the back two that we just did the domain for. And then your range answers this question. Hey, how high up can my graph go? How low down can my graph go? Okay. How low can you go? I've been singing. So, what's the highest this graph can go? That little arrow says forever and ever. How low can that graph go? It can only go down to 2, which means it has to be greater than or equal to 2. Do you understand this? How low can this graph go? Only to -2. How high can it go? For infinity. So this range has to just be greater than -2. Got it? You with me? Okay. So that is graphing your domain and graphing your range. Let's talk about, let's do this.